When I originally joined the Android DevRel team, I did wonder if I would forget what it would be like to actually work day-to-day on an app. And you do forget a little, not necessarily how to build stuff, nor how to code. We still do that a lot. But in general, like balancing your time between a new feature that the company needs you to build and the housekeeping that's necessary to ensure your Android app remains compliant with this policy or that requirement. And I actually had the opportunity to remember what it was like. So at the end of 2023, I spent a year and a half working as an Android developer in a very talented mobile team with a feature backlog as long as your arm. For the most part, that's what we'd be focused on, fixing bugs and adding new features. Occasionally, though, someone would flag an upcoming requirement. They'll be like, hey, I read something about a new requirement, something permissions, and if we don't fix it, we won't be able to update our app anymore. And in the great shuffle of feature tickets and bug reports, it's easy to forget and then panic when the deadline approaches. And I get it. In the spirit of demystifying these seemingly out-of-the-blue changes that are required of you each year, I want to provide a bit of a big picture context. In this session, I'll start by talking about the changes to the Android release schedule. This includes OS releases and, more importantly, SDK releases. I'll briefly discuss how those changes to the schedule relate to target SDK version and some context on how this target SDK version is being used internally, which should bring us nicely to the topic of play technical requirements, especially the one about target SDK version and the very predictable schedule for updates to this requirement. And if we have time, I'll give a highlight reel for behavior changes in Android 16, because I think that's what this talk is supposed to be about. Hopefully by then it should be a lot clearer why they're important, what we do to minimize the effort that's placed on your side, and hopefully inspire you to tackle some of these migrations as early as possible. The first thing, though, is to understand the release cadence, and by that I mean both the OS and SDK release. This is what it used to look like, more or less. So once a year we'd get a new major revision of the SDK, and this corresponded with a new version of the OS a few months later. And then once a quarter, we'd release updates called QPRs, and these contain new features, bug fixes, optimizations, but they don't contain API changes. And also once a month, we release security patches, and again, no API changes. Last year, though, we announced that we'd have more frequent SDK releases, which brings us to 2025, the first ever year in which we have multiple SDK releases. In Q2, we released SDK 36, which corresponds with Android 16. That was released in June. Next, we'll have our first ever minor SDK release, 36.1, which will correspond with the Android 16 QPR2, which will also be released in Q4. And why is this important? Having a single release window like we used to creates a lot of pressure for teams to ship features before they're ready. Smaller releases means less risk at each upgrade, and we now have more than one opportunity to ship APIs quickly after a need is identified, rather than waiting for a far-off release vehicle. And finally, we can align on new features and APIs more closely with hardware schedules, so new devices come with the new stuff. And I know what you're thinking, hang on, doesn't this mean more work? No. We'll only ship API changes in the major SDK release. Minor SDK releases will only contain new APIs that you can choose to adopt if you want, but if not, you can safely ignore it. The takeaway here is that we'll continue to have a single major SDK revision per year, but we'll also have optional minor revisions, which means it's good for users and no additional work for app developers if you're not interested. To understand how we can make sure that's the case, we have to look at target SDK version. This property lets the runtime know the highest API level that your app is designed to run on. This is different from compile SDK, which determines the SDK version with which you'll build your app. If you want to access new APIs that were released in version X, then you have to set your compile SDK version to X or greater. The Android OS can use whichever target SDK you've defined to change behavior for your app at runtime. So if it's set to a high value, then it knows it can use the latest behaviors because your app is designed to handle it. Otherwise, it will run in a compatibility mode. We can ensure that minor releases of Android don't contain intentional behavior changes because Target SDK uses the SDK int value, and these are the same for subsequent minor revisions of an SDK. The runtime has to assume the lowest common denominator, which is the major release, 36 in this case. The column on the right, though, shows a new property that's available from SDK 36.1, the SDK int full. You can use this constant at runtime to use new APIs conditionally, meaning if you want to use the new APIs that are available in minor SDK releases, you can. Target SDK version is one of the most important mechanisms that we have to ensure that the changes we make to the SDK are safe. Every year, hundreds of features comprising thousands of changes are submitted to improve the next version of Android. And for every release, we review these changes for something called app compatibility, which is a fancy way of saying, is this change going to break an existing app? If the answer is yes, then that feature has to go through additional review. So the overarching goal is to minimize the negative impact on users and developers. So we first have to ask, is the change even necessary? If it's just a change to an API to make our lives easier, that's not a good reason, and the change will typically be blocked. If it is necessary, then we'll work with the proposing team to come up with a plan to mitigate the impact. If there's no way around that, we'll use a Target SDK version to gate the feature so that it doesn't cause any immediate impact to existing apps. This means that new behavior will only apply if your app targets the next version of the SDK, which means it shouldn't break existing apps for users. We're also staging features with opt-in or opt-out flags across multiple versions of Android where it makes sense, so that you have more time to make changes. Unfortunately, though, you can't delay it forever. In 2017, we announced that the Google Play Target SDK requirement, which said that new apps must target a recent version of Android. Every new version of Android introduces changes that can bring security and performance updates, as well as new features. Since some of these features are Target SDK gated, they only apply to apps that have a high enough Target SDK version. This play requirement is a way to ensure new apps and apps that are being actively updated are keeping up to date with modern Android best practices. A great example of this is Edge-to-Edge, which launched in 2019 with Android 10. That was probably the best time to support it, and the second best time is now. Although Android 15 enforced Edge-to-Edge by default 6 years after it launched, you could still opt out with a flag, and as this person puts it, buy yourself another year. But when you target Android 16, there's no guarantee the opt-out will work anymore. By the way, if this comment is you, please see me after class. I think that's a great place to transition into the last part of this session, my Android 16 highlight reel. This is very similar, but also slightly different from the What's New in Android talks. So while those tend to celebrate new features, behaviors, and APIs, this one is more of a friendly reminder that the Google Play Target SDK requirement updates every year, and the next one will enforce targeting Android 16. So now's the best time to plan this work into your 2026 roadmaps. So at number 3, we've got Edge-to-Edge. Users love it. So apps that draw behind status and navigation bars feel more premium, according to an internal UX study. Edge-to-Edge became a recommended design pattern with Android 10 in 2019 with the new window insets APIs for drawing behind system bars. Android 15 enforced Edge-to-Edge by default, making the system bars transparent unless you opted out. And once you target Android 16, you can't opt out anymore. So it's really important to test your app with this feature so that when you have to target Android 16, your app is ready. Pay particular attention to screens like login to ensure buttons are not obscured by system elements, and test it with both the 3-button nav and gesture nav. In second place is Predictive Back, which debuted in Android 13 as an opt-in feature for developers. Users had to enable the option in developer settings to see it. Android 14 added support for more animations, like for those across tasks. And by Android 15, the developer's option toggle was removed, which meant that if your app had opted into this behavior, users would start to see animations by default. Android 16 also added more features, including a mechanism to observe back events without consuming them. Targeting Android 16 also enables this feature by default, so if your app isn't ready, you'll have to explicitly opt out. Again, this is a temporary fix and is not guaranteed across future versions of Android. And coming in at number 1, it's adaptive layouts. Adaptive layouts have been around in some shape or form since Android 1, and with the recent rise in popularity of foldables and the resurgence of large screen devices, it's more important than ever to make sure that your app works well across all form factors. When you target Android 16, restricting orientation, aspect ratio, or resizability is no longer allowed. These properties will be ignored on large screen displays. So we appreciate this has the potential to require a lot of effort on your part, so it will still be possible to opt out of this behavior, but again, that's only a temporary fix. Once you target Android 17, the opt-out is not guaranteed, and you'll need to fix any issues before that. The first step is to test your app on these different form factors running on Android 16, focusing on fixing the things that don't work and then come back to optimize for design. If you're interested in more, check out Francesco's talk tomorrow around noon on adaptive layouts. And finally, this gets an honorable mention. So 16 KB page size increases the size of the memory page from 4 to 16 KB, meaning fewer page loads are required, which results in, on average, a better performance. With 4.6% reduced power draw, 6.6% faster camera cold starts, and up to 30% faster app launch times, this is definitely something that we want to encourage you to do as soon as possible. While it's technically not related to the Android 16 changes, it's still worth a mention because a separate Google Play technical requirement will be enforced starting November of this year in anticipation of new hardware that will only support this new page size. You can use tools like APK Analyzer from Android Studio to check whether a pre-built APK uses native code and whether any of the libraries in it have alignment issues. And please do take the time to test your app on either a Pixel device running in 16 KB mode or with the 16 KB emulator that's bundled with Android Studio. And that's it. So if I can highlight 2 things for you to take away, they would be: check developer.android.com for the behavior changes by release. This is the easiest way to make sure that you're covering everything that you need to cover. It's available for every major release, and it has been since Android 6, 5. No, I've seen it for KitKat as well. And it's a very short list for each release. Secondly, also subscribe for email updates at developer.android.com/subscribe. This is the best way to stay up to date and also be notified about new requirements that aren't necessarily related to changes based on Android OS version. If you have any feedback or questions, please come and find me or my colleagues out in the hall. We'll love to chat. Thank you.